Hi, thank you for seeing this. I'm going to present the IoT Power Management Platform. What is the IoT Power Management Platform? So let me talk a little bit about the IoT chip. Nowadays, most IoT chips are composed by a number of IPs inside from different vendors. These IPs include SRAM, MRAM, CPU, radio, audio, USB, and monitoring functions. And to supply all that, you need a lot of power management. This lot of power management is usually a number of different IPs. It's the battery charger, are all the regulators that you need, maybe 5 regulators, maybe 10 regulators, maybe 2, depends on the system. And you need the monitoring functions with measurement like temperature measurement, you need oscillators, you need real-time clock, and many times SIM card interface. The RTC ends up being a backbone for the PMU that is used on IoT. The PMU on IoT is basically a PMIC that fits within the system on chip, the SoC, and that solves all the supply problems. We're going to talk about that later on. The RTC is that backbone that allows the system to have very low power modes, and then the RTC will keep all the functions that need to be alive all the time and wake up the system whenever it's necessary. So things like interrupts and real-time clock and alarm, all that is inside the RTC, and I'm going to explain that later. Okay, so what does this IoT PMU solve? It solves all those nasty problems that you have on an IoT chip, and that consumes a lot of time, effort, and sometimes doesn't differentiate you because you're better at doing other things. So one of the things that you have on the IoT PMU that you don't have on most of the other IPs is that you need to be compliant with high voltage domains. These high voltage domains have to do with the fact that you need to charge the battery. And that's usually 5 volt, and you need to support 6 volt compliance or even higher than that. You need the battery support, and the battery is up to 4.2 or even 4.5 when you're charging it. And you have the backup battery. Also, all these are high voltage domains, and you need specific devices to be able to comply with these. And normally the IoT chips are being designed on technologies that only support 3.3 or even less than that, 1.8 volts. So when you have a technology that supports 1.8 volts and you need to interface with the battery, with the charger, all that, these are high voltage domains that are solved by the PMU that goes into the IoT. Then you have the ultra low power functions, because you are doing IoT and you need to consume very little power, but you need to do things. And there are things that are not done by the microprocessor, that are not done on the high power modes, and they fit well within the PMU that goes into the system. And these things are monitoring voltages, interrupts, real-time clock, some standby regulators, for instance for the SRAM, if you need to keep the SRAM on retention mode. And you have, of course, the support functions. Those support functions are usually oscillators, temperature sensors, LED drivers, microphone bias, SIM card interface, GPIOs, all that also goes into the support functions and goes into the PMU. And of course the power on reset, which resets your system, and it's one of the most critical IPs, because if this fails, your system will fail basically. And then you have all that, but we're always talking about IoT or systems that need high performance, so you need good efficiency. And this high efficiency is usually done with very specific IPs, which are the DC-DC converters or charge pumps that have over 90% efficiency. And we'll talk a little bit more about the DC-DC converter, because on the IoT market, the DC-DC converter needs to be very efficient, but also very efficient down to the very low currents. So we now have the flexible IoT PMU. This flexible IoT PMU is something that will vary for every system. So how do we make a flexible IoT PMU for every system? It's done with a platform, and we have this platform for every foundry that we support, and also for every node and flavor. So you pick up the IPs from this library and you create your PMU. And this PMU will be your IoT PMU and will fit within your IoT SoC. And this has the real-time clock, the backup battery and battery support, the APC, which is the advanced power controller, DC converters, LDOs, and you pick up as many LDOs, DC converters or oscillators that you need, and you put all together into this PMIC that will be your IoT power management unit. But it's not enough that you have these IPs available. Each IP also needs to be configurable, because on power management, it is very rare that different systems will have exactly the same requirements. So for instance, your real-time clock might need to have, for instance, a crystal oscillator or RC oscillator, or even both, or even to have some anti-tampering functions that could require the both oscillators to be there. It might need to have interrupts, it might need to have other things, and you can configure your real-time clock so that you have an IP that fits within the PMU, which is configured and with all the functions that you need. And all these systems, all these that you fit together, then can be delivered with different integration levels. So depending on the nodes and depending on the customers, depending on the system, sometimes it's delivered with different IPs. So you have a net list and a number of IPs that are configured and have already a net list for integration examples that you can plug all together, but you need to route everything to create your PMIC. Or you can have all bundled with the bumps, with the ESDs, with everything, so that you go, plug it in, just connect your ground, and of course DVDD, and your digital lines to it. And this is a trend. You can see that over time, more and more, the PMU for IoT is being delivered as full integrated with ESD and with the bumps, so that it's very simple to integrate into bigger systems. Okay, so now talking a little bit about the advantages of this. So of course we talk about the flexibility, and the flexibility has to do with this ability to support very different systems from different markets, and it has to do with the fact that all the IPs can be plugged into a backbone that is composed by the RTC and the APC, the advanced power controller, and that allows you to do very different systems. But also each IP is very configurable, so that you can have differentiated products depending on your needs. And of course, all that with the low quiescent and the high efficiency for the DC converters, and the low quiescent that is available even for the DC converters. And all that together, you get a great product. But still, you are a little bit far from success, because having a great product that is just a GDS or that is on silicon is still far from success. So what is still missing, and what needs to be provided, and what we are providing at the moment for all our customers? Basically two things: very good IP characterization. And to be able to do that, it's normal for a PMIC to have over 10,000 lines of script, over 150 hours of automated data collection, of thousands and thousands of long lines of lots of data going into a database. And that needs to be data mined. You need to have high code reuse so that you can characterize many PMICs. You need to have automatic characterization because the amount of data that is collected is huge. And of course you need automated data mining so that you can do an automated report writing that allows you to have very nice reports that cover all the cases, all the use cases, all the options that you have inside the chip, and that allows a full characterization of the chip. On top of that, you also need support during the ramp up to production of your chip. And that support can be done many ways, and a lot of things are needed. Because of that, what we have done is to provide a full support where we support the ramp up to test with our characterization, and by replicating the same procedures used for the final test on the lab with automated characterization and with automated replication of this, but also with test guidelines based on that, and photo emission and infrared imaging so that we can support immediately the customer if something happens. And it happens several times that we detect things, for instance, while we are characterizing the chip. Imagine we are characterizing a chip and we see that the digital over every temperature cycle starts to consume more power. We immediately can ask the customer if they allow us to look inside the chip, and we'll look inside the chip and see what is happening. Where is the stress? Why is our data that is being collected changing over time? Because we monitor not only the power management part of it, but all the consumptions of the chip during characterization. So we have this photo emission, microprobing, package analysis, all that to support the customer and to guarantee that we are a partner through all the cycle. So from the system specification, when we work with the customer, specifying the PMIC, design and integration, chip level integration review, then the characterization, the production support with the test guidelines, with the replication on the lab of the same procedures, and again, with all the support, we can close the system and go for the next round with the customer for the next product with new features and new improvements for the next cycle. And this is very important because if you have a great product and you have a full cycle support, then that for us is powering your success. And that's what we try to do with every customer, is to power your success so that you have a full successful product in your hands and come back for the next project. Here is just a final slide and showing up where we are in Portugal, and we hope to talk to you soon. Thank you very much.